All right, so warm-up number 44 says compute the standard deviation for that sample using the shortcut formula. We have 100, 50, 30, 70, and 120. And let me see I'm going to send you one from your colleagues. All right, that one looks about right. Double check your work. And if you got something like that, all right. So, copy the agenda. Once again, warm-up number 44, measures of variation, and have an excellent day, but more specifically, have a safe afternoon, guys, and doesn't go like without saying that make sure you consume stuff that's safe. So be careful with some of those candies and such, because there's crazy people out there. So also make sure if you're walking the streets, careful also. Somehow, I don't know what happens, like when there's special days or whatever, people forget how to drive. I'm like, come on guys, same thing, just be more careful. My goodness. All right, we good? Yes, thank you. All right. Copy the code for tonight, or for this presentation, UKM5C, UKM5C. All right, so it's going to go a little fast, but I think we're there already. So before we continue, once again, you are to study your formulas, yes. How many do we have total? Tell your neighbor. Yeah, so far 14, okay. All right, so get a Cornell note ready. I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. I will be uploading this video after lunch, so if you need to revisit, today's going to be a little bit, we're just going to go one step further. I was going to say farther, but farther is distance, and further applies to away from in the concept. So, measures of variation. Tell your neighbor the definition, or two words that would work as a definition for measures of variation. Measures of variation. What would be the key words? Keywords. All right, good conversation. Looks like Diego's got this. Diego, two words. Okay, close. I was looking for variance and spread. Variance and spread. Variance, that it changes, and spread, that the data is being spread. And we see that in the bell curve, right? And what are the three measures? Range, standard deviation, and variance. Okay, we got that. Data measures. Remind your neighbor, please. What are the three that we are working towards, and the three of each of the individual ones? Tell your neighbor. So we got it, yes? All right. So once again, here go the formulas. Let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. So all of these we've been working with so far and well. However, when we started with standard deviation, what do we need in order for us to find standard deviation and variance? Talk about the neighbor. What do we need in order to get that going? What do we need? Looks like Mia's got it. Peyton's got it. Very good, Peyton. Caleb's got it. Well, let's go with Jaden. What do we need, Jaden, in order to find the standard deviation? Numbers. Let's go. Also known as data. Yes? All right. So, that is true. However, what happens when they give us a table? You're like, what? Yeah, look at this one. It says, the data represents the number of miles that 20 runners ran in a week. Compute the sample variance and sample standard deviation of the frequency distributed data. What do we do with that? Well, we use a different formula. Because now we're dealing with what? What is this column? Frequency. Therefore, check this out. Bam, let's go. Copy. I told you yesterday we're adding more, right? So copy those two formulas, please. Let me move them towards the center. So now we have 16. Here they are. That one and that one. And these are for the variance, if you want to label it, variance and standard deviation of grouped data. Let me repeat that again. Variance and standard deviation of what? Grouped data, which means data in a table. I'll give you some time to copy that, and then we'll break it down to make sure we understand what we're looking at. Go. All right, so let's break this down. Let's see, who went last? Jaden? Okay. Start with Jaden then. That was a good one. Anyway, let's start with this formula for the variance. So it's sample variance for what, guys? Once again, we titled it what? Group data, right? Okay. So let's break it down. Looking at the formula, it's sorry. Let me move this up. Make sure we know what we're looking at. All right, so tell your neighbor what the N stands for. All right, Jaden, pass someone. Joel? Yeah, number of numbers, yes. All right. Everyone, sigma stands for sum, yes. How about this symbol? Everyone, frequency, yes. Times, what does the X, check this out, the X with a sub M stand for? By now you should know. Talk to your neighbors, see if they remember. X sub M. Joe, pass someone. Diego. M. Midpoint. That is correct. The midpoint of the data. And what data do they give us? If they give us a table, it's by class. Is that correct? Yes, and they ask us to square that. Okay. Minus, and of course this would be obvious. Yes? All right. So now that we have that, therefore, copy this table, please. Class, frequency. How many classes did they give us? Let's see. 1, 2, 3, 4, 5, 6, 7 classes. And here's the frequency of those. You don't have to copy the problem, but let me read it again. The data represents the number of miles that runners ran in a week. Compute the sample variance and sample variation of the frequency distributed data. So copy the table, and all the way to the far right, I want you to write the formula for the sample variance of group data. I'll give you some time. So once again, you wrote your formula on the right-hand side, and we said that what information do we need? We need the midpoints. So here we do another column, F for frequency, X sub M for midpoint. And how do we find the midpoint? Pass them on, Joseph. Peyton, how do we find the midpoint of the first class? Add the two boundaries and divide by 2. So what is 10.5 plus 5.5? That's 16 divided by 2. That is 8. Okay. We got that one. Next one. 10.5 plus 15.5, that's 26 divided by 2, that's 13. Yeah. Next one, 15, 35, 36, that's 18. Next one, 23, Michael Jordan. Yes, am I good or? Yeah. 56, that's 28. That's 66, that's 33. And the last one, 76, that's 38. Hands, have you got that? Yeah? All right. So let's see. What information do we need? Do we have F for frequency? Yes? Do we have the midpoint squared? We don't, right? So let's do another column and do midpoint squared. All right. So, Diego, go. 64. 13 times 13, 169. 18 times 18. Fernando, go. 324. 23 times 23. Areli. What is it? 549. I can't hear you with the AC. It's too loud. Oh, 29. My bad. 529. 28 times 28. Caleb. 784. 33 times 33. Clarissa. Couldn't hear. 1,089. Let's go. And 38 times 38. Dylan. 1444. All right. So, do we have enough information now to substitute? Yes, Mr. Q. So, let's do that. Parentheses. Minus. Parentheses squared. Parentheses. So, first of all, question. What is N? Tell your neighbor what N stands for. What does N stand for? And here's the problem again. Look at it. Read it. What does N stand for? All right. Dylan, pass someone? Ooh, I get to pick someone. Jaden, what does N stand for? Close. Remember, it was the number of numbers. How many total numbers? 20, that is correct. So this is our N. Label that. So we got 20. So what do we write on the denominator? 20 times 19. Okay. Next, I'm going to use pink to highlight this part. What does that say? It says frequency times the midpoint squared. Frequency times the midpoint squared. So that means I'm going to need another column. What? Calculators, calculate. I'm going to label this one in red. We got S times X midpoint squared. So, give me the first one, Diego. 64. So that means the frequency times the midpoint squared, which is this. All right, so 1 times 64. So the next one is 2 times what? 169, so that's 338. Yes. And then 3 times 324, that's 972. Am I good? Yes? No? Maybe so? Let's go. 5 times 529, that's 15, no, that's 16, 25. What is it? 2006-45. Yeah, I did that on purpose, see if you guys got it. 2645. All right. 4 times 784. What'd you get? Peyton. 3136. All right. 3 times 1089. That's 3,000. 270 minus 3. That's 267. All right. And 2 times 1444. That's 2888. But they want us to do what? They want us to do what? The sum, yeah. So find me the sum of that. Sum. All right. 64 plus 338 plus 972 plus 2645 plus 3136 plus 3267 plus 2888 is 13,000 what? I'm sorry? 310? And that goes right here. 13,310. Woo! That was good. So now what? I'm going to change to the highlighter to green for this part. Which means what, Ms. Q? That we need another column. Ah. All right. So therefore, what do we write here? The frequency times what? The midpoint by itself, right? Because there's nothing else inside of the, and then we find the sum at the end for that. All right, so, Diego, we'll get us started. Bam, Diego. 115. Is it 112? and then 99, and then 76. So find me the sum of all those, guys. 8 plus 26 plus 54 plus 115 plus 112 plus 99 plus 76. What you get for the sum, Lenny? 4 what? 490? So 490. All right. Calculators calculate. We got 20 times that. So let me just add a 0. And then 2 times 2 times 0, 0. 2, 6, 6, 2. Is that correct? Yes, Mr. Q. You're the bomb. All right, thank you. What is 490 squared? 490 squared. It's like 20-some thousand, yeah? What is it? 240,100. Over 20 times 19 is 380. So variance is 266, 200 minus 240, 100. So that is 26,100 divided by 380. So the variance of the group data is it like 60 something? Oh my goodness, I got this. Let's go. 60 what? Let's see. I think Jaden's got it. 26,100 divided by 380. 68.60. Like that. Now I'm going to put the wiggles here. It's approximate. Are we done, everyone? No, Mr. Q. So that we need the standard deviation, which means you need to take the square root of that. So square root of 68.68, it's 8 point something. Let's go. 8.28. And that's the way the cookie crumbles. Let's go. So what did we do different? Pretty much we just found, according to the table that we built before, what was the name of this column in the class? What? When it has the decimals, it's called what? What is it? Starts with the letter B. Boundaries. Come on, people. Boundaries. Because before boundaries, it's just called class what? Tell your neighbor. Yeah, before that, it's class limits. Yeah. You're like, okay, I think I remember. Remember, guys, that we do the limits first, then we do the boundaries, then we did the frequency, then we did the midpoint. Isn't that the same process? So what's the only thing that we added? The midpoint squared, and then the frequency times the midpoint squared, and the frequency times the midpoint, and then we find the sum for both. So like that, we can use that in our formula. From 1 to 5, how comfortable are you with this? Yeah, 5 fours, 5 fours. Yeah, we just need practice. Now, Mr. Q, why are you telling us about the setup of the table? Well, what if they give us data that's not in the table? then look at me. He's all, are you serious? Hold on, hold on. That was good, Peyton. So, according to, hold on, let me go back. According to what we have here, let me just read you off this really quick. It says, passenger vehicle deaths. The number of people killed in each state from passenger vehicle crashes for a specific year is shown. Find the range, the variance, and standard deviation for the data. Now, are we going to organize all these numbers from least to greatest? It's too much stuff, right? So what shall we do? Tell your neighbor, what shall we do with that data? Let's see if they know what to do. What shall we do? What do you think, Joseph? What's that? No, it wouldn't be rule of thumb because I want it exact, or at least close to. What do you think, Diego? Yes. What do we do with all this data to find the measures of variation? Yes, we put it in a table. That is correct. And what do we start with? What's the first column, everyone? Class, what? Limits. From there we go to class boundaries. And you're saying, wait a minute, Mr. Q, but they didn't give us how many classes. So let me ask you this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 50 data. How many classes do you want to divide that into? Think when we did our tables, guys. How many classes was the usual range from where to where? How many classes? Anywhere from 5 to what? 10? All right. So how many classes do you want to do? 5? Okay. So then write it on top, 5 classes. All right. So in order to get started, remind your neighbor, what are the first 2 things that we need? What are the first 2 things? First 2 things. The range and the width. That is correct. All right, find me that, and then Diego's going to enlighten us since he's really focused today. My goodness. Bah. I'll wait for that answer. Range. How to find range? Okay. Tell us what to write, Diego. Hold on. Let me make some room here. 2,786 minus what is it? Minus 65. So my range is 2,721. Okay. Therefore, how do we find our width? 2721 divided by 5, which are the classes. Therefore, 5 what? 555? 545? No decimal? Okay, so it was 544 point what? 3.2. So it goes up to 545, okay. So that's our width. So, what number do we start with, guys? See if you remember, tell your neighbor. Our table, what do we start with? Very good. 65. And then we add what? 545. So that gives us 610 on the next class. And then we add 545 to that. So that's 1155. Then we add 545 to that. That gives us 1700. Is that correct? And then add 545 to that. That's 2245. Let me move this over. So, 65, that's the lower limit. What's the upper limit? Jaden, 609. And then, yes. $2,700 and what? It goes exact? No, but what are we going by? 65 all the way to 609? 530 what? 544? 544, so that's 2789. 2789. And so on and so forth. Do we know what to do from there, guys? Yes, pretty lengthy. So, I'll stop the video right here, and we're going to continue going. Class boundaries, from there frequency, from there midpoint, and so on and so forth, and then we use our formula, yada, yada, yada. All right? Good afternoon, guys. Enjoy your afternoon. Be safe. Bye.